This ESRI application allows users to see carbon dioxide concentrations and its variation across a city or any given area of interest. More than half of the global population lives in urban areas, which are the heart of industrial activity. Hence, cities are responsible for almost 70% of greenhouse gas emissions globally. This is why our team focused on helping cities see or measure their carbon emissions. So our team chose the city of Barnsley in the United Kingdom to display the carbon dioxide concentrations on this application. In this map, we can see the CO2 concentration estimates for May of 2021. You can hover your mouse over each of the different land use polygons and notice the concentration of carbon dioxide. Furthermore, you can zoom in onto this map and see the land use types such as roads, houses, suburban and urban areas, highways, and even observe the names of each of these locations within the city. NASA's OCO2 satellite data was used to derive the carbon dioxide concentrations. These measurements are done in cloud-free regions in longitudinal strips which can be visualized. Here's a spatial map of the amount of carbon dioxide present in columns of the atmosphere below NASA's OCO2 satellite as it flew over the city of Barnsley between May 2015 and May 2021. Owing to cloud cover, there was a high degree of missing data over the city of Barnsley. To resolve this issue, the OCO2 data was interpolated using a cubic Hermit spline method to fit the global seasonality trend observed in the global CO2 data from the Mauna Loa Observatory in Hawaii. After interpolation, the output was a gridded product which was hosted on ESRI's ArcGIS platform. The city of Barnsley was then divided into land cover polygons from the Urban Atlas service, and the monthly CO2 concentrations were predicted for each land use type. This was done using ESRI's JavaScript libraries and map layers. Along with the static map, we have a time lapse of these concentrations between the 2 years, 2015 to 2021. And you can play this by clicking the play button here, and it will automatically change by month. So you can see the change in monthly carbon dioxide concentrations with the same legend as before. In this time lapse, the transformed OCO2 data shows a clear difference between 2015 and 2021 for the different land covers. In terms of color code, the greener the color, the lower the carbon emissions level, and the redder the color, the higher the carbon emissions. So let's go through our story map titled Mapping the Urban CO2 Emissions from Space. We can scroll down and the introduction on carbon emissions along with how the data was collected and processed to create our application is described in detail. Then we can go to a section titled Exploring Barnsley. So our tour begins in the west of the metropolitan borough of Barnsley near Penistone, which is a small town close to Barnsley. This is a countryside region which is predominantly rural with farming on rich, well-watered soils. And this map is from 2015 and it represents green areas because of the lower carbon emissions. Now scrolling down, we see an interactive slider. The left-hand side is representing the map from 2015, whereas the right-hand side is from 2021. And as we can slide back and forth, we see that Penistone, which was formerly a green area in 2015, is now in red or dark red. And this is because of the increasing carbon emissions as of 2021. Barnsley has many natural sinks consisting of woodland and peatland, which are huge stores of carbon. If areas like these are degraded or burnt, they could release tons of carbon emissions. Now scrolling down further, we can see motorways. So we see this large red line crossing on Barnsley's territory in a slight diagonal from north to south. This is showing a high level of carbon emissions as it is dark red. Road transportation emissions represent 15% of carbon emissions globally and are a big challenge to cities when it comes to reducing them. And for our final stage of the tour, we see Barnsley City. This is Barnsley City Centre, and we can take a look at A268, which is a major road crossing, a dense area of buildings. This map is deep red in color, reflecting that the emissions in this area is particularly high. Making the unseen seen does not stop here. In addition to helping cities see their carbon emissions, this data helps them decide on the most strategic measures to put in place, as well as monitor the impact of these measures.